Okay, so the way to think about it looks a bit like this. Our XOK has got 5, 6, 7, and we assign X to be 1, 2, 3. Operating system has its own way of thinking, all right, and os.xok is equal to 1. And that is inside. So actually there are two locations, two containers. They are named with the same given name, XOK, but different surname. Different surname. Without any referencing to surname, like nothing dot something, we are talking about our own global variable name. With the surname given, OS dot, we are talking about that family's, that module's variable name. Okay. More about namespace and scoping. So the scoping is going to be responsible for unique naming across different modules. We may import OS, OS2, math, time, date time, whatever. We can import a lot, maybe even hundreds of modules. And even if all of them use some sort of XOK, it is still okay, right? There's no clash thanks to namespace and scoping. That means, what is scoping? Scoping is the extent of referenceability. To what extent can a uniquely named variable through namespace be referenced, be valid? Okay, so even though module establishes its own namespace, and therefore the scope of those variable names are inside the module, a function also dynamically creates a new temporary namespace as it runs and destroys that temporary namespace as it returns, as it exits a function call. All right. So here we are defining a function. Remember, a function is another possible control jump by Python. So whenever we call a function like this, we are making Python jump to the function name called SumProfit, replacing X with the profit 1, replacing XOK with profit 2, and then calculating whatever is inside. And finally, the function exits by returning a value coming out, and the whole value here is replaced with the value that the function returns. It's a bit like calling sine of 10 degrees or exponential 1. What is the value? So it's the same, except we write our own function. So having said that, that's the purpose of having a function, because we can reuse it and all that. We can talk more about that in the function series of videos. Here, my main focus is more about referenceability. So outside here, we have a variable x, right? Inside the function, maybe because we write it some time back and we were thinking about x, maybe because we ask our teammates to, can you please write the SumProfit because I'm busy with the rest of the global code. Maybe this, maybe that, right? For various reasons, which I think you can understand, people will use X, kind of ignorant and also not caring about whether other people use X or not. Yeah, because this makes sense to me. X is what I want. So when we use X in the global namespace, and this X here appears within the function, it may seem like a clash, right? But there isn't. Number one, the name within function definition is local to the function. It's local. Okay? So that means the X here is a new container. And whenever within the function we refer to X, it is about the X that is within the function. And likewise, if we have a SumProfit 2 that also uses X, there will be no clash. All right, but that's interesting because it is only during a function call. This is a function definition. We just defined it. We didn't run it. So despite it using X and X here, Python actually doesn't care what you do here until the function is being called. Then an error may be generated depending on the situation. So here we try to print out what is X, but this is not referring to the nearest X or whatnot. It is referring to the globally defined X. Then we say XOK, which is this, all right? Then we calculate SumProfit. And we pass this x, what is this? This is this global x, into the function where profit 1 now has the value that the global x has, which is going to be 789. And the XOK is 345. So this profit 1 will be 789, profit 2 will be 345. We add them up, print out something, all right, and the total of profit 1 plus profit 2 and returning. So we just print some indicators for us to see what's happening. And we return the total of profit 1 plus profit 2. This time, returning the value, not the container, the value. So what's the value? The sum, right? And replace and assigning that value into the container called total profit. Okay, so we don't put the whole container X into the container called total profit. Rather, we put the calculated value, the thing inside, make a copy of it, and assign it and put it inside the container called total profit. Now, if we refer to X, what happens? This is where the dynamically generated namespace provides the scope through which the X is being accessed. So when we called sum profit, a new scope of reference has been created. It is part of our global namespace. It is sitting inside that our program, so it's part of our program's global namespace, but it creates its own namespace. So that means when you have the same given name X, the same variable name of the container, it is a new container. It's not the same as the global X. So when we assign it with a total, and that's fine. It's not overwriting the global's X. It's still 789. When we return the value of X, it is the 1134 that is being returned, not the whole container called X. All right, so the 1134 is being returned and assigned to total profit variable inside the global namespace. And then when we look at our X again, no change. It is still 789 because nothing has been done to this container called X in the global namespace. So if you understand the namespace carefully, this is totally clear. You just write whatever you want. You don't have to check with anybody. Please don't use my X because I'm using it. You don't have to do that. So it makes a lot of sense, a lot of reusability. We can ask our friends to help write this function and not to worry about can you not use X because I'm using it? Can you not use XOK because I'm using it? And so on. Okay, so with a quick copy and pasting, and the annoying part about this is that we need to debug a little bit. Fortunately, it's not that bad. Okay, so returning from profit with the quotation mark. And we see that it should print out the results that I have recorded and shown on the slide. Okay, so we make a function call, even though we haven't covered function, but that's okay because you can just think of the sum profit like sine, cosine, exponential, just a function call. And we are very familiar with that. And we are also making sum profit return a value like 1134, right? So this really behaves like as if it's a program that as a function that we are quite familiar with. All right, and we need to do this. Total profit, and we're done. So what happens when we run? Let's just clear the console and run it again. Okay, so before the function call, X, let's confirm the value of X. We access the container called X, 789. We access the container called XOK, 345, which is fair and square. Despite the definition here overwriting X to be some other yet to be defined values. So the definition of it is just a placeholder, just define it there. Python actually doesn't execute the statements inside the function until there is a function call. So the def here is a defining part of the function. We're defining it, we're making a placeholder there. we perform a function call when we actually start with a bracket and passing any, if any, necessary parameters to the function. So this is a function call. This starting with def is a function definition. Only when we perform function call does Python create a new temporary dynamic namespace in which the local variables have scope. That means they can be referenced, they will be uniquely referenced, they will not clash in name, even though your global outer namespaces contain similarly named variable names. Okay, so let's just look a bit further. So in profit function, we are inside now. We are inside here now. Profit 1 is 789. Profit 2 is 345. Not surprising. We add up the values and we assign it to a container, a variable name called x. But this x is a new container, right? And returning from some profit, we return. Upon performing return x, number one, the value of x is taken out and replace whatever function name is being written. Here. So it's as if we perform a total profit equals to 1134 here. Number two, the dynamically created temporary namespace is totally deleted, like as if it doesn't exist in the first place. So you can continue to use x, you can refer to x, and it is now still properly registering the global x, the global value, and that's not being disturbed at all. That's great, right? So we can just feel free to use any names. And namespace and scoping, they might at the first encounter feel very complicated or unnecessarily complicated even. But I hope you now get to see the benefits of it. The fact that it's totally independent choice of naming variables, regardless of whether you're sitting inside somebody else's program or you're running it on your own, or some existing system functions or built-in modules have already used the variable name of your delight and your choice. You don't have to avoid them. You can still use them. Why? Thanks to the namespace and scoping mechanism.